Distillation is a separation technique used to separate a mixture of liquids that have different boiling points. It's also used to separate a liquid from the materials dissolved in it. In this pod, we'll look at how distillation is carried out and a few ways you can use distillation in the lab.
A very simple set of equipment for distillation consists of a conical flask placed on a tripod and gauze. It's heated using a Bunsen burner. The conical flask is held on the tripod using a clamp stand.
The conical flask is sealed with a bung. The bung contains a delivery tube which leads to a test tube. The test tube is placed into a cold water bath which contains a mixture of ice and water.
An example of a mixture that can be separated using this equipment is salt solution, which is a mixture of salt dissolved in water. The solution is added into the conical flask and heated until it boils. The water will turn into steam and travel through the delivery tube and into the test tube, where it condenses because of the cold water bath. Pure water will collect in the test tube.
The salt solution and the pure water will look exactly the same, as they are both colourless liquids. You can't tell just by looking that any separation has taken place. However, you can carry out chemical tests to show that the mixture contains salt and water, and the pure water contains no salt. One example is to do a flame test, which tests for the presence of sodium ions. A piece of nichrome wire is placed into one of the liquids and then into a blue Bunsen burner flame. If sodium ions are present, you will see a bright yellow flame.
This simple distillation equipment can also be used to separate mixtures such as orange juice, cherry cola, and ink, which is a mixture of a coloured pigment and water.
In order to separate out liquids with different boiling points, such as a mixture of hydrocarbons, different apparatus is needed. This time, the mixture is placed into a round-bottomed flask called a distilling flask. This is heated using an electric heater and held in place using a clamp stand. Attached to the neck of the flask is a thermometer.
To the side, a Liebig condenser is connected. This piece of apparatus has a jacket through which cold water continuously flows from a tap. The other end of the condenser is placed above a small beaker.
This apparatus can be used to separate a mixture of ethanol and water. Ethanol has a boiling point of 78 degrees Celsius, and water boils at 100 degrees Celsius. You place the mixture into the distilling flask and add a few anti-bumping granules. These help to control the boiling to stop it from being too vigorous. This reduces the risk of the flask cracking.
To carry out the distillation, you heat the distilling flask using an electric heater. The thermometer is used to monitor the temperature. When it reaches 78 degrees Celsius, the ethanol will start to boil and turn into a gas. The gas will travel down the condenser, where it will condense and turn back into a liquid. The pure ethanol will drip into the beaker.
It's important to control the heating so the temperature does not rise above 85 degrees Celsius. This minimises the risk of the flask cracking and also ensures that the water does not start to boil. You can test the liquid produced by placing a small amount into a glass watch glass and touching a lighted splint to it. Ethanol is highly flammable, so it will be set alight immediately.